Hi, my name is Steve Rahi. I am a premier field engineer specializing in management technologies. Today's discussion is part one of a series focusing on caching options in Configuration Manager Current Branch. Topic today specifically we'll start to talk about pure caching. Actually, pure caching will be broken down into two parts. This is part one. Part two will also focus on pure caching, but then specifically that session will focus on OSD. The implication is, or the fact is, pure caching supports both standard deployments in Config Manager and OSD, but there's a little bit of difference between OSD and standard pure caching, so we'll save those differences for part two. So jumping into the session, bit of an agenda. What is caching in general, and then what is Config Manager pure caching, and why do we care? What are the requirements for it? A couple of scenarios and how it works, configuring it, a demo for you on that, and then watching this work in action. We'll wrap up with a bit of troubleshooting tips and tricks, and we will be done with part one. Okay, so what is caching, right? And this is not a Config Manager specific discussion. This is just caching in general and pretty self-explanatory. Basically, caching is a mechanism to optimize network usage. It's a scenario in which you have offices remote and you're concerned about network latency or slow connections or whatever, and you want to take advantage of using local resources, but you don't want to have to put out a lot of infrastructure in the Config Manager world, distribution points, in order to support that. So caching will help you do that. We'll use this definition kind of as a stage for the whole series. Just generically, what is caching, then we'll dig into each one of these pieces in the series to talk about it in more detail. On the right-hand side, branch cache, pure cache, delivery optimization, third party. We're talking about pure cache right now, that's the highlight, but we'll get to the other ones as well. The only one we won't talk about in the series is third-party solutions in the Config Manager world. That's 1E Nomad and Adaptiva OneSite. Those are third-party solutions, so we won't include those in this series here, but do want to at least call it out as an option for you, right? In addition, so caching leverages local content source peers. Now, I'm using that phrase to describe systems that will provide content to peers on the network. Right? That's kind of my phrase that I use to describe it in Config Manager. If you look in the logs, even though this isn't yet a Config Manager specific discussion, this is just generically what is caching. If you look at the Config Manager logs, you will hear or you will see the term super peer. So this is one that actually can host content, and the super peer vernacular the super peer kind of adjective is really describing specifically a system that's configured for peer caching, right? So if you see super peer, that's referring to peer caching. But I just generically refer to anyone who serves content to another peer as a local content source peer. That's just me, so I could probably share it both ways as we go along. But again, in the generic frame in which we're talking right now, in caching, we can leverage those local content source peers for content acquisition for Pixie Boot. And this is something that, again, there's partners out there that help with that. This is something that is currently, as of this recording anyway, it's in the technical previews of Configuration Manager Current Branch. The Pixie Responder Service is what it's officially called, right? So, but that's definitely a place where content will come from, boot images, things of that nature. Also, caching, to make caching work, you have to be able to define and group the peers where you want caching to happen, generically speaking, with things like branch cache and third-party solutions and so on. You typically think of subnets doing that definition. So if you have clients on the same subnet, then they can share content with each other. In the peer caching world, that is not the way we do it. We do it with boundary groups. So that, again, is a kind of a Config Manager specific topic coming into this generic discussion of caching on this slide, but something to be aware of, and we'll call that out more as we go along. And then finally, what is caching? Enables reduced infrastructure in the Config Manager world. That is distribution points and other caching discussions. It could be other things, right? But that's generically what it is. Now, what is Config Manager peer caching now being specific and turning our page to be specific in Config Manager? Well, potential peers, so same thing. We're going to be doing caching, but we're going to be using the peer caching mechanism. So what is the mechanism to define who the potential peers might be? It's a combination of boundary group settings and boundary group membership. So we'll talk about how those two are working together or can work together as we go further a little bit. This is a solution native to Config Manager, so there is nothing else you need to install. It's in Config Manager, supports all kinds of content lookup, including OSD. Again, we'll get to that in session 2. So it's a native tool. And why do we care? Again, because it is native. It doesn't have any additional cost associated. It's self-contained. It's available for you to use today. We care because it helps us reduce our infrastructure footprint. Again, in the Config Manager world, that's distribution points. Also helps us reduce network traffic of downloading whatever we're going to download. Some of it can be pretty big, right? And then finally, decreasing content download times. If we have big content, it's cached, or even whatever size content, if you can get it from a peer versus going across a slow network link, it's going to be much faster to acquire that content. What do we require to set this up? One of the requirements is to have your super peers domain joined. So these would be what, again, I refer to in the previous slide as content source peers. Those that will receive the content and seed the or store the content and make it available to others are your super peers. Those systems must be domain joined. Now, that doesn't mean that the peers that would retrieve content from the super peers have to be domain joined. They don't. It's just the super peers that need to be domain joined to store that content and so forth. You do need to have boundary group configurations. Now, this is an interesting topic because some networks are sufficiently complex that maintaining boundary groups is a bit cumbersome. I'm thinking of several customers right now that are in this situation. In fact, many of them don't even run with boundary groups, and that works fine because of the way they're configured. You do need boundary groups here, but there's ways to optimize the boundary group so that you don't maybe have to be as finite about it and be as exhaustive in figuring out your network as you can, right? So I'll say this here, and I'll probably jump ahead and say it again later, but specifically in the boundary group configuration, that is the caching boundary for peer caching. And so the idea is if you are a content source peer or a super peer within a boundary group, then you are able to serve content to any other system in that boundary group. But there's also configurations on the boundary group, I'll show you this in a minute, where you can specifically say, yeah, these systems are part of the same boundary group, but I don't want these systems just because they're part of the boundary group to be able to share content back and forth. Instead, those systems need to be on, sharing content need to be on the same subnet within the boundary group. So it helps you further refine, and it also offers you some opportunity. And that opportunity is, if you have a very large network, instead of having to pull all of the subnets and subnet ranges and things like that and be very specific on the boundary groups and have hundreds of boundary groups to define different configurations, you can maybe reduce the boundary groups and have 4 or 5 really large boundary groups, or 10 or 8 or whatever the number is. And those really large boundary groups are then used to control peer caching, but then there's also that configuration on the boundary group that ultimately can control it by saying only let systems on the same subnet communicate and share content, right? So again, it's an option. It makes it possible to use boundary groups and be a larger view of the boundary group itself, but be finite inside the boundary group and control of who gets to talk with whom. And again, I'll show you that in just a minute. And then you also need the Config Manager client. And that Config Manager client, as long as it's running on a supported operating system, then you can use peer caching, no problem. In fact, I specifically will show in a demo a little bit later where my super peer, my content source machine, is on Windows 7 serving a Windows 10 client. Do that on purpose to show that it works great on a Windows 7 machine, no problem. All right. So scenarios, how does this work, right? First, scenarios. There's two big umbrella scenarios. One is imaging. I put an asterisk there. I'm calling out imaging just because it is a supported scenario, but as already mentioned, I will not be talking about imaging in this session. That will be saved for session 2, where we will dive into the uniquenesses and how to set up imaging. Works with standardized imaging, pre-staging content to content source peers works that way too. And then the second big umbrella is standard deployments, anything besides imaging, right? So how does it work? How does ConfigMgr work with this whole content location scheme to figure out where a client needs to go in order to get content? Well, when we're talking about peer caching, the assumption is that there's at least one peer, one super peer, one content source peer that has this content to serve out. If there is nobody that has the content to serve, well, at least one machine will have to download that content from a traditional distribution point, right? Once that client has the content, a super peer is enabled with the content, has it, then we use this content location selection priority. So if your client is on a DP, then we will prefer that DP. If it's a peer in the same subnet that has content, we will prefer to go to that peer, even over a DP that's in the same subnet. Then if we have a peer in the same boundary group, we will prefer that over a DP in the same boundary group, and then neighboring and default, and on we go. And you notice cloud DPs are able to be used, but they are last in the list, and as they always have been, just because there's a cost associated with it, right? So we'll see this work to about this stage in the demo that we'll do here in just a minute. So how do we go about configuring this? Well, to drive this discussion, let me bring in the lab, and we will go that way. Okay, so let's pull this in. I'm going to close this window where some updates are showing up. All right, so first, boundary groups, right? So I've already talked to you about boundary groups, but let's go look at them specifically. And so if I go into hierarchy configuration and boundary groups, okay, so I have a couple of boundary groups. Let me just look at the properties of this one. Well, first of all, the boundary group defines the scope under which caching can happen. So within a boundary group, if you're looking at the boundary group as a whole, and this rule is true regardless of whether you're looking at it as a whole or not, you do need to have at least one content source peer in a boundary group in order for that boundary group to be able to be used for peer caching at all. Now, once you have that, then you can consider your network configuration, consider your specific scenario. Should you be looking at the boundary membership as a unit, meaning anyone in that boundary can talk to the super peers that are in that boundary group? Or should you be looking more finitely or more focused at the boundary group and what it contains, and make a decision about, even within the boundary group, what are we going to focus further? And specifically, that's here. Allow peer downloads in this boundary group. So that's even more of a option that we can start with. By default, all boundary groups are enabled for peer sharing. But you don't have to enable that. If there's a boundary group somewhere that you want to exclude from sharing for some reason, you can do that. Just turn off this box, right? But then if you want to be more specific and say, hey, even within the boundary group, only use peers within the same subnet, that's where this checkbox comes into play. Now, in my lab, it's very simple. This isn't turned on. All I have is one subnet, so it's really not a problem for me. But in complex environments, it could be, right? We're talking about boundary groups here, and so as a part of talking about boundary groups, we have to also think about fallback and how that works for being able to get content out to your super peers. Right? There's a whole strategy that we'll get into about how you do deployments. We'll actually talk about that next. But just here, while we're here, regardless of how you do your deployments, you will need to get content out to your super peers so that those super peers can cache it and be able to share it around to others that need it. And so one of the considerations is the idea of setting fallback on your deployments when you push those deployments out, right? Because if you do enable fallback, if you send a deployment out to a super peer and tell it that you can't fall back to a DP that is not within your boundary group, what if that boundary group the super peer is in doesn't have any DPs defined? Another way to say it, if your super peer is in my boundary group here, I'll just use a specific lab group. If I have a DP or a super peer in the lab group boundary group, but I don't have any preferred traditional distribution points in that boundary group, and I also don't set fallback on my deployment, then that super peer is going to get the deployment and not be able to do anything with it because it cannot get the content from a distribution point, right? Just a consideration to understand, right? And if you then send a deployment out to a group of systems that allow fallback universally, then it's conceivable that some other systems due to policy polling cycle, and again, the way you do your deployments, more on that in a minute, will start to receive the content before the peer does, and so you'll have more traffic across that network link, and at least initially, than you would once the super peer downloads the content. So just understand the implications of fallback and factor that into your specific configuration. Okay. So that's talking about boundary groups. Now, what about enabling peer caching in general? Okay. So the way we enable peer caching is through client settings. And I have an enable peer caching client setting here deployed to a collection of one machine that has peer caching turned on. So here we go, enable ConfigMgr client full OS, yes. And also I'm changing the maximum cache size. Why am I changing the maximum cache size? Because if you have peer caching enabled, the idea is that you expect that machine to need to hold on to content longer than other systems because it's going to be sharing it with other systems that might need it, right? So just keep that in mind as well. When you're whenever you're deploying the client setting to turn on peer caching and allow this sharing between systems, there's a strategy to think through about how you do that. Do you want to turn on peer caching to all of the systems in your network? Maybe, maybe not. Probably not, right? Because peer caching works great whenever you have the disk space to accommodate it, and you have a sufficiently powerful system that it's not going to be impacted by having other systems connect to it. But that may not be the case for every system you have in your environment. You may have some low-powered machines, maybe some embedded systems or similar. You may have some systems that don't have sufficient disk space. So it may be that you want to turn peer caching on to 80% of the systems, and the other 20% no, right? You can control that with the collection membership that you use, the criteria for it, whenever you build a collection of systems that will be super peers. Or it may be that you just want 5 or 10% of your environment to act as super peers. Again, that strategy is really up to you. How you enable this, how you adjust your cache size, up to you. I've actually got a collection down here, enable super peers. Where I set that up, again, it's just one machine, and it's my Windows 7, well, if I can get my system to refresh, it's my Windows 7 system that's in here on purpose. Come on, refresh. There we go. So interesting, it's not showing online, but it will be. I just powered these VMs on, so that's probably why. Either way, right? So along with your strategy about who will be content source peers, who will be super peers, comes along some strategy around your deployments as well. So I will mention this here. Okay. So if you set up a scenario where only 5% or so, just to pick a number, of your environment, a limited section of your environment will be super peers, then you have to also build a strategy to make sure that those super peers get the content. We'll talk about that in just a minute. If you set up a strategy where the vast majority of your enterprise is going to be super peers, then you may or may not need to do anything to manage that content on the super peers, right? So again, we'll talk about that more in a minute. So once we have the super peer actually configured, then we can go and validate that the super peer is actually running and ready to serve content. So I have a Windows 7 machine, as I mentioned. So let's just go into that Windows 7 machine and validate that it is turned on to be a super peer. So I'm going to pull that into my lab and apologize for the resolution. It is Windows 7. Okay, so let's open up. I'm going to use WMI Explorer to do this because it's just easier. And I'm going to connect to my local machine and go to CCM. CCM. Come on. If I can get it expanded. There we go. Machine or policy, and then machine and actual config. Machine, actual config. Okay, I'll double click on that. And so in machine actual config, there's a setting called CCM super peer, which is where the name comes from that I've been saying, super peer client config. Double click on that. Here's one instance. And so you can tell right here that I have different things configured. Let me see if I can move this away. Yeah, can be super peer, true, right? And then scrolling well, okay, so this is enabling super peer. There's other settings for your cache size and so on, but this will tell you at least that this system has received the instruction to turn on the ability to be a super peer, right? So we've got it turned on now. We're about to see it actually work. And here's a diagram of kind of how it will work before we get into the minutia of it. So here's a group of systems that all are going to be in the same subnet as this super peer. So I ultimately need to get, I'm just going to, policy polling cycles are random, and so I don't know that this is going to be the first one to hit all the time. There are ways I can force it, but just for sake of argument, this is going to be the first one to hit policy polling cycle. Step number one, the content source peer is going to request the content. There is no other place for it to get it besides a distribution point, and so the management point returns the content location, and it only has the distribution point. So then we get that. Step number three, the content is retrieved from an available distribution point, and then notice 3B, once we have the content downloaded, then the client sends a notification to the management point to say, hey, I am now available to be a source for other systems that need this content. And so a question may come in, I'll show you the details of this in a minute. How does ConfigMgr know that there's a super peer out there that is now ready to serve the content to other systems? Great question. The way that works is by sending state messages through a high-speed return to the site server to notify the site server that content is in place for a given system. So it happens very, very quickly. The one thing you want to be aware of is not to have state message backlogs, because that can slow the processing and slow the uptake for a system notifying that it has content. Here's another thing, and I'll probably share this again in a minute. If you go delete content from the client cache and you do it the right way, then there will be a state message that also goes up to tell the site, I don't have that content any longer. If you do it Steve's way, the way that I'm just such in the habit of doing and just deleting the folders, that state message will never go forward, and so you might get the site returning a content source peer that actually doesn't have the content. So just make sure you do these things in the right way and let the tools do any deletion of the cache that you want to do, especially on super peers. Okay, so that happens. Okay, great. So then the content is cached on the content source peer, the super peer. Now one of these machines will request the content. And so the management point returns the content locations and includes both distribution points and content source peers. Because we're in the same boundary, same subnet, we will preferentially choose the superpeer and download the content from there. So that's in general how it works. Now let's go see how this actually works. Let me pull back in the site server for a minute. Okay, and let's see. We have our collections configured correctly. We have our superpeer created. Now we need to deploy some software so that we can actually test this thing. So let's go talk about how we handle this before we even get it. Well, I'll show you the deployment, and then we'll get into a couple of scenarios. So here I have just a batch file test thing that I'm going to be using. But whenever we approach deployments, there are really two options. The first, and this can marry up to which scenario you use in terms of enabling superpeers. If you enable every one of your clients in your environment, or the vast majority of your clients in your environment to be superpeers, then you probably don't need to worry about doing anything. You just do a deployment as normal. You expect that a superpeer will get the content really quickly. And yeah, you might have a little bit of a network hit from other non-superpeers, the few systems that are not superpeers getting the content first. But very quickly you'll get a superpeer that gets the content and then can just serve it as normal, right? So you don't have to really manage that process. But it may be that you enable the peer caching with just a small percentage of systems in your environment. So you decide to manage the process of maintaining the content in those superpeers yourself. Either way is fine, and it can work depending on the scenario. So here's my content. But before we get into actually deploying the content, let me show you an example of how you might, if you do choose to manage the content yourself and you want to have control at that level of what gets into the cache, what versions of software gets into the cache, those kinds of things. Right? One of the ideas is that you can use a task sequence to manage the process of loading that content into the cache. So I have a task sequence here that you can use task sequences to totally manage what's in the cache. And so we typically think of task sequences as imaging. Doesn't have to be imaging, can be whatever, right? In this case, it would just be a task sequence you would run on a system. The whole purpose of it would be to download that content. And think about it also this way. If you have the vast majority of your systems configured to be superpeers, then it stands to reason when you do pretty much any deployment, you will hit some superpeers, right? You have to be careful to make sure that's the case, but it stands to reason that you would. If you have only a small percentage of systems that are enabled for superpeers in your environment, then it stands to reason that you will have a hit and miss kind of scenario depending on the deployment. In other words, when you have only a small percentage of systems configured as superpeer, you likely won't be including those superpeers in every deployment you would send out. So you would need to make sure that the content is available on the superpeer so that those systems that are going to be receiving the deployment will be able to get it from the superpeer. So a way to do that is to use a task sequence. And so this is a very simple task sequence, seeding my superpeer, 3 steps really. So setting my SMSTS persist content to true so it stays in the client cache, and then I'm using the download content step to seed my superpeer. In my case, I'm just downloading one thing, but you can download whatever you want. If you want to do boot images, whatever you need, all of that can be used from this step. And then finally, I'm setting the variable to preserve content after I exit, and I'm good, right? So that's one way to do it. In my case, I'm just going to do a standard deployment to my superpeer first, because I have control over it in my environment. I'm just going to run on the superpeer first to get the content local, and so on. Okay. So let me go ahead and pull in my Windows 7 machine, which is my superpeer, and go ahead and run my deployment. So if I look in the cache of the system, I don't recall whether it has content in it or not. It doesn't. Okay, so we're completely clean. So if I then go to Software Center and look, I will have software here ready to go, downloaded to me so that I can install it. Okay, so here we are. And so here's my seed super pure task sequence. That's not what I'm going to run here. I just have this simple batch file test, and I'm going to reinstall it just to get the content downloaded. So it's downloading, and now it's in my cache, and you see it's all here, right? So if I go into the logs, I'm going to go ahead and close this out. If I go into the logs, I can sift through and see where this actually came from. So looking at the standard log locations, two that I want to really focus on. First is the CAS log. And if I look, it will show me that I found one location, a standard distribution point where I can pull it from. No other places have been found at all, right? So if I go into Content Transfer Manager, I will also see that same thing. Just go in there, Content Transfer Manager. Let's check it out. So I will see that it's starting the job and where it's going to get it from. So downloading, actually I don't think this is verbose and debug logging turned on. So, but it's downloading. And then if I go to Data Transfer Service, I can see that as well, and it's referencing just the standard distribution point for downloading content. So I'm good. And so that's hopefully a reminder to me when I get to the other system to make sure it has verbose and debug logging turned on so you can see the difference. But if not, hopefully I remember that. If not, I probably will remember it when I look at the logs. So we've seen, now we're completely good to go. We have the content. This is our super pure. It got it from a distribution point. So let me pull in my Windows 10 system, and then we will see what happens there. So first things first, I'm going to make sure that the content is not here that I'm trying to get. So let me look in the Windows CCM cache folder. And in fact, the cache folder is empty, so we're good from that perspective. And then also, just to make sure, I believe verbose and debug is enabled here, but just make sure. So go into the registry, and so I do see that I have the debugging logging key. That's one of the things I need. And so if I see that, I'm certain the other is there as well. But let's look. So at global, so this is set to 0. So that's good. Okay, good enough. So we're good with this. So now let's launch Software Center and go run the same piece of deployment, run the same deployment and see what happens. Then we'll look at logs and see if there's anything that's different. So letting Software Center come up, and here it is. So run this test. And so we're going to get the content, and we've got it now. Should see it flash in just a minute. And then we will we'll be good. So we're getting, see it still working, and any second now we should be good. It's taken a little bit longer to download, which makes me think that this is going to get what I think it's supposed to get, so that's good. So the content's here. Now let's go and look in the logs, and we will start in the CAS log, just like we've done on the other. And so in the CAS log, and this is in Notepad, but that's all right, we'll just scroll down. In the CAS log, we see references here to pulling the file. Let's see if we can quickly scroll up and find the reference to where we're getting it from. I can keep scrolling, but that's okay. So let me go directly to, just so I don't have to keep scrolling, let me go directly to Content Transfer Manager and Data Transfer Service, where we can see that right away. So Content Transfer Manager will say where we're actually getting this from. So scroll up a bit, and right here, this is now coming from not my distribution point, but my my client peer, and I see that it's CCM branch cache dollar. So don't be fooled by that. This is not branch cache working. This is actually peer cache, but it's just referenced that way. And so let's scroll on up. So persisting locations, here we get both, just like we're supposed to get both. We get the traditional distribution point, and we get our peer cache location. And you see the order of 0 over here for CTM job in the order of 1 for CTM job. So CTM job is getting both, and you'll see in the return, this is a subnet peer, right? And so we're going to go ahead and use that one preferentially based on the selection logic, and we're good to go. And so just as a extra level of seeing things, so we can go to the data transfer service log and scroll down, and then we'll see actually the files getting transferred, and you can see they're coming from the peer cache through bits and so on. So that easy, we did in fact pull from peer cache preferentially and work just the same as before. But there's another piece to this that I want to show you. So the first thing I need to do is go ahead and reset this again and get rid of the content. I'm going to run this thing one more time and take another level at this. So let's get rid of the cache information. Delete files. Yes. All right, good enough. And then I want to run this again. But before I do, I want to actually make sure on the management point that, let me pull this back out and get back to the site server, which is the management point. I'm pretty certain this one's set right now to have verbose and debug logging turned on, but let's be sure. And so for those who aren't maybe familiar, the client and the management point share the same framework. And so turning on verbose logging for the management point is the same process as turning it on for the client. So let me go to CCM, look at logging, and look at global first. And in fact, verbose logging is turned on here. And we also have debug logging. Do we have that entry here? We do. So we should be good from the management point perspective. So what I want to do is run this again. And this time we're going to look at it from the management point level. Just click reinstall. So I'm going to let that go ahead. And so what's happening is we're going through a normal location request, just like we did before. And this just ran. And so we're good to go, right? And so let's just confirm again what we thought or what we think should have happened. And that's it came from our Windows 7 machine. I'll just take a look at data transfer service here just to confirm that real quick. And looking here, indeed, it came again from data transfer service, so that's cool. And so let's then trace this. So what happened was, one other place I'll show you real quick. When the client goes and asks for the content, it actually does a location request. And you can see that location request in the location services log, part of it anyway. So you can see the location services log here. And then if I trace that back up a little bit, let's see if I can find that. Content location reply. So that's probably the one, yeah, that I care about. So that is the content location reply. This is actually easier to see whenever you do have trace going on, but nevertheless, it is here. Let me go ahead and cut this. So this is the reply actually coming from the management point whenever the content location request is handled. So I'm going to open up another instance of Notepad and just turn on word wrap so that we can see this a bit better and paste that in. So this is the location request reply, right? And you can tell that it's seeing that we have as an option our peer cache, system and all that. But how does this location request actually get processed? How does it happen to return this value on the client? So to answer that, we can go to the site server. And by the way, we're here on the site server again. You see that the peer cache content host or the super peer turned green. It was just a matter of I hadn't powered on the VM very long ago after we started. Anyway, so to look at that, I can look at the log, the corresponding log for location requests, and that's under on a management point where the management point installed first. It's under SMS_CCM logs and then MP _location right here. So if I open that up and expand it, let's see, go all the way to the bottom because this is there. Scroll up. So basically here's the processing for it. And so you can see a couple of things. First of all, this is one of two stored procedures. This one is the first stored procedure. So this stored procedure has always been around to find the content location when we had traditional distribution points, before we ever had the option for peer caching. And so that's what this returns, is traditional distribution points. But now that we have peer caching, then we have this distribution point, or I'm sorry, this stored procedure as well, that will look to see if we have any super peer information available to us, right? So I'm going to copy that to the clipboard. The one thing also that I want to do, we're going to dig into, I'll show you this in just a minute. Won't do it yet. But the other thing, I'm going to pull the client back in, the Windows 10 client. So the Windows 7 client, not the Windows 10. I want to show you the super peer machine. So you saw that we downloaded the content, we put it in the cache, and you saw just from my Windows 10 machine that we did retrieve it from this super peer. But the question is, how does this super peer tell the site that it now has the content? And the answer is that as soon as the content is cached, it will send up a state message. And so let's look at that in CCM and logs. And this might have rolled a little bit, but let's go see if we can find it. So state message, right? And so let's see. So let me try to sift through this just for a minute, because there's a whole bunch of state messages that go back and forth. And I want to find the right one. Actually, it's probably faster for me just to go find the ID of that content and then look for it here. So let me go get that ID and I'll come back and look for it by that number. So that is SAP0002F. So let's go find that. To Foxtrot and go up. Okay, so basically, this is a state message. So whenever you add content to the cache, and it's a peer cache super peer, we will use a state message to say this content is now in the cache. Whenever you delete the content from the cache, we will also send a state message to say this content is no longer in the cache. And so that's what this is, has been. So this is removing this content, right? If we do another search, we can add this content. And so these state messages move up to the site very quickly and need to be processed very quickly by the site so that the site knows that these systems are available to serve content. So again, said it before, but make sure that your state message processing on the site server is happening in a quick way. All right. And last thing that I will show you about state messages, let me pull this system out again, minimize it, and I will also get rid of this system temporarily, get rid of it. I want to show you a sample state message. So let me pull that in. So typically you're not going to capture state messages. This is an SMX, but I captured it here for you to show you that even in the state message right here, this is an older package ID. It's just one that I've kept around to show you. It's cache remove, and you would have an equivalent cache add actually in the state message, and that's what will flag it in the database to indicate that the machine is or is not a system hosting the content. And then to follow that all the way through, let's go ahead and go to the site server and look in the database for a moment and pull in SQL. So let's grab that. All right, this is back to the site server. Let me get rid of this log. And then down here, I have SQL open. So anytime I go into SQL, this is just a look, don't touch kind of thing. It is not supported at all to edit any of these database tables. If you feel like you need to, this is something you need to do with support. But this is just to kind of give you an idea where this information is stored, how it's stored, and it's sometimes helpful to be able to look at this and see some information for troubleshooting purposes and so on. So if I go down to the super peer tables, so down here are 4 tables that will list super peers, and it will list what content's there. So this, first of all, is a table that will show me all of my super peers right now. So I just have one, so it'll just be one machine in here, as you see, right? And then also I can go up to super peers and look and see what particular content might be on there. And so this is my content map. Actually, that's not it. This is what I wanted, sorry. This is my content map. So it shows me, hey, this package right here, or this content ID is there, and so forth. So it's nice to be able to see this and draw parallels or use that for troubleshooting or sanity checking or whatever the case may be, right? Last thing as we're walking through this, so just like most components, the peer caching piece has available reporting as well. It looks like my console is frozen, so let me close that and relaunch it. Hang on. Okay, relaunch. So if I go to monitoring and look under reporting for reports and search for peer cache, or just peer, that's probably enough, I will have these 3 reports. So peer cache source content rejection, source content rejection by condition, source content rejection details, right? So at least I can monitor and see how my peer caching solution is doing for me and what kind of hit rates I'm getting, any challenges with it, and so on. So that's kind of an end-to-end through peer caching. And again, we didn't talk about OSD. We will talk about that in the next session. But you hopefully have an idea now kind of how peer caching works and some elements you might need to think through and decide for your environment, right? And so let's kind of start to wrap things up. So peer caching, troubleshooting tips and tricks. We've talked about a number of these already, but we'll just kind of highlight them again. So in terms of troubleshooting, we do have a number of things that are at our disposal to help for. First, whenever you're looking in the client logs, you can tell if the client is using a peer cache location by the URL that is listed for where the client's going to get the content. It would have that sccm_branch cache $ in the URL. There's the SMSTS log. In the case of OSD, we're not talking about that. There are the traditional content location logs, the CAS log, the content transfer manager, the data transfer service logs. And then in the case of letting the site know that a given super peer has or does not have the content, that's the state message log on the client side. On the management point side, it's the MP_location log to track location requests, and there's a specific stored procedure in there that we looked at, MP_get super peer content locations. In fact, that reminds me, let me just pull back in my site for a moment. There we go. I think I closed SQL. That's okay. I will quickly relaunch it. And I'll just show you that that stored procedure. It's kind of fun to look at sometimes when we launch Management Studio again. And then we'll go in and look at that stored procedure. While that's loading, also on the management point, there's a log called MP_relay. So I didn't show this log to you specifically for state messages, but that is the log that is used to manage state messages in transit from the client to the site server. It goes through the management point, and MP_relay can be helpful. And then finally on the site server, the state sys log, trying to do too many things at once. Let me go to programmability. That's what I want, stored procedures. So the state sys log on the site server is where those state messages actually get loaded into the site. So let me scroll down here for a minute, and I will show you the stored procedure that we are talking about here. So MP_get super peer content locations. So if I click on this and modify, then you can read through this stored procedure. If you're familiar with Transact SQL commands, you'll be able to kind of follow this and understand how it works and so forth. And this is what helps populate that list I showed you at the beginning of this session that dictates the selection priority for where to go get the content and so forth, right? Okay, so that's the logs. And then in WMI, I showed you where you can go into WMI and verify on the client side that a client is or is not valid for being a super peer. That's in root CCM policy machine, actual config, and then the class is called CCM_super peer client config. You can look at that. There is one as well for OSD, but we'll talk about that next time whenever we talk about OSD. And then finally, Just a trick, a little tip here in terms of previous versions of ConfigMgr. This is hopefully long in the rearview mirror, right? So content source peer rejects request for content. So you might have a machine out there that's going to reject the request for content. And I believe this was as of 1702, and past that it's fixed. But this is specifically for OSD, right? And so peer caching for OSD was introduced into the product before standard peer caching, like we talked about today, was there. So it would make sense that it would be around 1702. Nevertheless, prior to then, if a machine was in low battery mode, or the CPU load exceeds 80% of the content time, or disk I/O had a greater than 10 average queue length, and maybe some other scenarios such as no more connections on the workstation, then in fact we will reject that system. In fact, I said this wrong when I described it. As of 1702 forward, these are now considerations. So we don't want a machine that is in a low battery condition to act as a peer cache, so we're going to exclude it. If the CPU load is above 80%, we don't want that system acting as a peer cache machine, so we will exclude it. If disk I/O is really, really heavy, we don't want that machine acting as peer cache, so we will exclude it. Prior to 1702, those checks were not in there for OSD, right? So sorry I said it wrong at the beginning. Hopefully that makes sense, right? So all that said, and the demo's done, that wraps up what I wanted to share in terms of peer cache for this session. We will talk about peer cache again in session 2 coming up next, and we will talk about it then, and see you next time.